For this series of videos, we want to talk about how we create our tables and graphs for quantitative variables. And the example that I want to start us off with has to do with the presidents and their ages at inauguration. So on the screen, you'll see that I have a lot of information about the presidents, both age at inauguration, year, number of children, and age of death. We're going to focus on age at inauguration. Age, you'll remember, is considered a quantitative variable. And right off the bat, I notice that if I scroll down through this list, I have a lot of unique values for their ages: 57, 61, 58, 54, 49, and so on. Previously, when we talked about qualitative variables, we were able to graph those qualitative variables using a bar graph. But a bar graph doesn't make a whole lot of sense here in this case because I have so many values or possible ages that are occurring, I would just end up with too many bars and not enough information about the general sense of this data. So let's first talk about how would I summarize this data into a table. We know that we have raw data here in this column, and in order to take the data and create a table, we're going to look at both a frequency and a relative frequency table. To do that, we go to Stat, Tables, Frequency, and I'm using the age at inauguration column. And because we already know the differences between frequency and relative frequency from a previous video, we're going to select both of them and click Compute. You'll notice that StatCrunch put a pop-up up here. It says, whoa, you've got a lot of unique number values for this column. Do you want us to bin it? Let's click yes, and let's see what happens to that. So here's the table that we just created for both frequency and relative frequency, but notice what happened over here for the age at inauguration column. This was what StatCrunch was referring to. There were too many individual values within that raw data, and so instead what they did is it grouped it. Notice here that StatCrunch just automatically grouped it by 40 to 45, ages 45 to 50, 50 to 55, and so forth. What happens when we do this is it's called binning the data. B-I-N-N-I-N-G. We're grouping or binning the data. We are creating classes of the data is another way to refer to that. In essence, all we're really doing is creating categories of ages. We're grouping the presidents by ages of 5. Just like our qualitative tables for frequency and relative frequency for each category, this table tells me that there were 2 total presidents who had ages between 40 and 45, which was roughly 4% of the presidents aged 40 to 45. And so we would interpret frequency and relative frequency on this table in the same manner that we do for our qualitative variables. Now, as we spoke before, this is one way for us to summarize our data into a table, but we want to specifically talk about now how do I create graphical displays for quantitative variables. And that's going to look like a histogram. So the first graph we want to create is called a histogram. Let's go to Graph, Histogram. Age at inauguration is the column we're specifically referring to, and we're not going to do anything else currently. I'm going to come down to the Compute section, and I've now created my histogram. So if you're looking at this histogram and you're thinking that looks an awful lot like our bar graph we created for qualitative variables, they're similar in that the width of the bars are all going to be the same, just like they need to be in a bar graph. They're similar that the height of the bar tells me the frequency from within that particular bar. But the major difference between a bar graph and a histogram has to do with the fact that these bars are all touching. That's a characteristic of a histogram because I kind of want to start to get an overall shape to this histogram, which we're going to see in another video. So again, if I hover my mouse over a particular bar, you'll notice that it tells me that in this particular bar, there were 12 presidents. And then in the box that popped up, the yellow box that popped up, you'll notice that on the left-hand side of 55 is a bracket, and on the right-hand side of 60 is a parentheses. In the math world, when we see brackets and parentheses like this, that indicates that the bracket is telling me that I can include the number, so I'm going to include the number 55, but the parentheses says I go up to but don't quite make it to the 60. So parentheses mean you don't include that last number. This is indicating then that for this particular bar, we're going to look at ages anywhere from 55 all the way up to, let's say if we needed to, 59.99999, because that's just shy of 60. Okay, so I'm not including 60, and the reason for that is because when I hover my mouse on the very next bar, you'll notice that the bracket is now at 60. So I'm going to include 60 in this particular bar here. If I had included 60 in the previous bar, then that would have been double counting that particular age. So we are going to include the left number, but we do not include the right number in this particular designation. If I move this bar over, this graph over here, come back to my graph option, and let's pull up age at inauguration one more time, relative frequency. Put these two graphs side by side. I hope you can see that both of these graphs are going to indicate exactly the same thing, right? There's really no difference between the two graphs. The only difference is coming from what's over here on the left-hand side of the scale, where I can clearly see one is a relative and one is a frequency histogram. You want to keep in mind that when we're looking at our histograms, I want to kind of be able to see the overall shape. So whether it's a proportion or total count, the shape of that graph is not changing. Let's look at one more idea here in our histograms. I'm going to go to the applets, pull up histogram with sliders, and let's go back to our age at inauguration. So here I've got something I can play around with for a minute. Remember, we let StatCrunch set the width of our groupings. So StatCrunch automatically grouped the president's ages by 5s. So I have a bin width of 5. But that doesn't mean that that has to be the bin width. I can change the bin width and I can tell it to be whatever I want it to be. But let's see what happens when I do change it. I'm going to take the slider bar and move the slider bar to the left. So I'm going to make the width of the bins smaller. So rather than me grouping presidents by 5 years of age, I'm going to group them by 3, 2, 1. And you'll notice that as I adjust the size of the bin, right, the width of the rectangles are becoming skinnier, and I'm also getting more of them. So each one of these rectangles is going to contain data, but I end up with more of them. Okay, so let's go back to the 5. That's where we started from. So when I made the bin widths smaller, I ended up with more bars, and I also had skinnier bars. Let's move in the opposite direction. This time, notice that these bars are getting fatter or thicker, and I have fewer of them than when I started. So you can see that there is really multiple ways for us to be able to bin. Ultimately, I want to create a graphical display that's going to give me some generalization about the shape of the data that we're looking at. So, if we want to think about histograms, a couple of things that you need to understand about histograms. First of all, you would determine that class width or the bin. If you had to draw it by hand, you could. Remember that your height is equal to the frequency or the relative frequency of that class or bin. And then another characteristic of our histogram is that all of the rectangles are going to be the same width and they are going to touch.